In this video, we are going to discuss about chain rule, total derivative and implicit function. So let's have a look at the first chain rule. Suppose there is a function of u, that is z is equal f of u, where u is equal to g of x1, that means u itself is a function of x and y. We can determine del z by del x and del z by del y. So whenever we consider this kind of, so first I have to assume that this one path, that means that is a one variable function u, so write dz by du, and that u is a function of two variables, so but we are going to focus only one variable, that is x, keeping y constant, so that's why we use del u by del x. Similarly, del z by del y, so we have the path through u, so first we assume that the path through u, so we have z is only one variable, so we have to use dz by du, and then u is a function of two variables, so I have to use del u by del y. And if we assume that the total derivative, if u is equal to f of xy, where x is a function of t and y is a function of t, so our tree look like that one. And suppose I want to determine total derivative, say du by dt, so in that case du by dt can be evaluated by del u by del x into dx by dt, because this is the one variable function, that's why we use dx by dt, plus this is a two variable function, u is a function of x y, so I say del u by del y and into dy by dt, and that is our total derivative. But suppose we have given it a function of three variables, u is a function of three variables, x, y, z, x is a function of t, y is a function of t, and z is a function of t. So in that case, what it will be the total derivative? Du by dt will be del u by del x into dx by dt plus del u by del y into dy by dt and del u by del z into dz by dt, and that is our total derivative whenever we have the function of three variables. Now let us look at the first question. W is equal xy plus z and x is equal cos t, y is equal sin t, and z is equal t. Then find the dw by dt. That is it. We want to find the total derivative. So w is a function of x, y, and z, and x is a function of t, y is also a function of t, z is also a function of t. So I say this is t. That means this is one variable. So I have to assume that only here derivative, ordinary derivative, whereas here I have to assume that the partial derivative. Now look at the first dw by dt, and that can be written as del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. But for that I have to first concentrate del w by del x. So w is there, so partial derivative with respect to x is going to be what? Only y, and dx by dt, x is equal to cos t, so we can determine dx by dt, so it is going to be minus sin t, so we get here, and del w by del y, so it is going to be x is a constant and that is a constant quantity, but derivative with respect to y will be 0, and dy by dt, so it is going to be only cos t, and after replacing here, and plus del w by del z, so it is going to be concentrate on this one, and this is the constant quantity, so it is going to be 0, and then del z by del z, that is going to be 1, and again del z by del t, sorry, dz by dt is going to be 1, so we get this one. But after simplifying, you will get this one. Still you can simplify, so cos 2t plus 1. Also we noted its formula 2 times cos square t is equal dw by dt. Still, if I say dw by dt at particular point say t is equal 0, so what it will be? So we can say 2 cos square 0, but cos 0 is nothing but 1, so what we are going to get? Only 2. So this is our final, but according to the question, we need to determine dw by dt, and that is we have. Now let us consider this question again that you can do. I'm not going to focus in details. That is a function of x, y, and x and y both are function of t, and that you can do using the chain rule, or you can set total derivative. And our answers will be in terms of z, in terms of t. Okay, because dz by dt, what it says, we want derivative with respect to z, We want derivative of z. Z is nothing but dependent variable and t is nothing but independent. So whenever we see that this kind of derivatives, so our answers will be in terms of independent variables at t. So final answer is 16 times e raised to cube t cube plus 10 a cube into t raised to 4. This is another question. So again you can see that z is a function of xy. So here you can represent x and y. X and y both are function of u and v. And now we want to value del z by del u. That means I have to assume that this one path both way. That means del z by del x into dx, del x by del u. Why we are using here del x by del u? Because x itself is a function of u and v. That's why we are using del x by del u. Plus del z by del y into del y by del u. And for that, what we have to determine del z by del x. So z is there. So we know that 1 divided by 1 plus x square, but x is replaced by this quantity. So x square plus y square is there. X square divided by y square is there. And then derivative of x divided by y with respect to x, that is going to be 1 divided by y. And del x by del u, so this is that. So del x by del u will be only cos v. Plus we want del z by del y. So 1 divided by 1 plus x square divided by y square into del y of x divided by y, that is minus x divided by y square, and then derivative of y with respect to u, that is going to be sine v. But whenever you simplify, so what you are going to get, y times cos v divided by x square plus y square minus x times sine v divided by x square plus y square. But x square plus y square is there. But whenever you simplify, so you will get this one, and this is what exactly 0. 0 divided by y square plus x square, so you will get the answer 0. But we want to determine at this one point, that means del z by del u at point 1.3 comma pi divided by 6. Also we will keep in mind that z is dependent, u is independent, z is dependent, v is independent. So our independent variable is u and v. So this is what exactly u comma v. So whatever we have determined, so that is answer is 0. So for any choice of u and v, so what we are going to get, that is the answer 0. Now look at another. That is again we want del z by del v. The same procedure we are going to follow here. Whenever you simplify, so what you are going to get, 1 divided by x square plus y square divided by y square. But y square can be written here and divided by y, so 1 y is there. And this is minus u sine v. This is not cos, only minus u sine v. And the same argument we can apply here, derivative, whatever we have derived, and just do the simplification. So 1 divided by x square plus y square divided by y square, so y square can be written in the numerator. But when we simplify, so we are going to get minus x and u cos v. This is not a sign, so we have u cos v. But whenever you see that x is equal u cos v and y is equal u sin v, and that is what exactly given. So if I suppose to replace u sin v, and that is going to be what exactly y. So minus is there, again minus is there, so minus can be taken out common. So we get y into y, that is the y square, minus plus, because already we have assumed that minus common. So what we are going to get, x into x, that is x square, but when we simplify, so we will get this one. So at particular point, del z by del v at 1.3 comma pi by 6, and that is going to be what exactly minus 1, and hence this is the solution of this question. Now let's have a look at another question. If u is equal f of x minus 1, y minus z, z minus x, then prove that del u by del x plus del u by del y plus del u by del z is equal to 0. So when we look this question, so it is quite difficult whenever you see, but when you have the chain rule, so in that case it is going to be very easy. So for that, what we have to consider? For our simplicity, we are assuming that x minus y is equal to L, y minus z, that is m, and z minus x is equal to L. So that our function itself becomes what? So u can be written as f of L, m, n. Suppose I want to determine del u by del x. So it is clear that u is a function of lmn and lmn are functions of what exactly? X, y and z. So we can say all these three functions l, m and n are functions of x, y and z. But when I do partial derivative with respect to x, so in that case u itself is a function. So I just write as it is. Otherwise you may write del u by del l and then del l by del x. So just keep in mind that suppose you want to find your del u by del x. So this is the one approach, plus this is the second, plus this is the third. So I'm just going to consider del u by del m into del m by del x, plus del u by del m into del n by del x. So whenever you find here del u by del l, so it is going to be same, and del l by del x. So L is equal x minus y is there, so its derivative with respect to x, that is going to be 1. Now del u by del m is there, and del m by del x, this is n, del m by del x, but this is not the functions of any x. So this is going to be constant, so its derivative will be 0. What about next? Del u by del n. So whenever we do partial derivative with respect to x of this function, so what I'm just going to get? Minus 1. So I'm just going to get del u by del n minus del u by del n. So this is equation number 1. So similarly, you can determine the remaining del u by del y, and after simplifying you will get a minus del u by del l plus del u by del m. Say equation number 2. Similarly, you can find del u by del z is equal this formula, and using that formula also you can determine minus del u by del m plus del u by del n. Say equation number 3. Now adding equation number 1, 2 and 3. So you will get answer that is 0. Now we have the implicit function. So first, implicit, what is the difference between implicit and explicit? So when we say that the function is implicit and explicit, suppose you have given that y is equal f of x. I'm just talking about the y is equal, which depends on only x. So it is known as explicit. But the y is not directly dependent on only one variable. Say xy is equal x square plus y square. So from this, x cannot be written as function of y, or y cannot be written in function of x, and therefore this function is known as implicit. So clearly, if any function of the type f of xy is equal c is called the implicit function. For example, this one, this is same as this one, because x cannot be expressed in terms of y, or y cannot be expressed in terms of x, and therefore this kind of functions is known as implicit function. So in such cases, how we can determine its partial derivative, or we say ordinary derivative dy by dx, and that is we can determine using this partial derivative, and that is we are going to discuss. So let us first see, if f of xy is equal c, where y is a function of x, that means y itself is dependent on x and c is a constant, and we want to determine dy by dx. So how we can say this one, and this is known as implicit differentiation. I'm not going to remember these things, but first I'm just going to focus only this one. This is the given. I want to determine dy by dx. So first start with the partial derivative with respect to x. So total derivative we can have df by dx. So df by dx is equal to 0. So this can be written as what? Del f by del x. So I just assume that f is a function of x and y is a function of x. So if I follow this chain, so it will be very easy to determine whatever I'm just going to determine. So I'm just going to focus x with respect to x, that is going to be 1. So I just want df by dx. So in that case, del f by del x, because f is a function of two variables, so del f by del x into dx by dx plus del f by del y into dy by dx, and that is equal to 0. But this is what? Exactly 1. But I want to make dy by dx as a subject, so what I'm just going to get? Minus del f by del x divided by del f by del y, and this is what exactly f sub x, and this is what exactly f sub y with the minus sign. But whenever we observe this kind of, so we will always keep in mind that we need to consider level surface. That means f of xy is equal c. Then after we will determine fx and fy, and if you suppose to given that dy by dx, so in that case you have to follow that dy by dx. So minus sign we will keep in mind that x is there, so we will write here f sub x, and numerator contains y, so we will write here fy. So that will be the easy to remember. So ultimately using this formula, you can determine the dy by dx. So now let us consider this question quickly. So this is our level surface, f of xy is equal, this one is equal c. You can assume that, but c is nothing but here 0. When you find the f sub x, so we get 3x square, because y is a constant quantity, so it will be the 0. And 3ay is a constant, so derivative of x with respect to x, that is going to be 1. Fy is there, so also dy by dx you can determine, so minus del f by del x divided by del f by del y. But when we replace all these value, and I just take minus common, as well as I take 3x, 3 common from the numerator as well as 3 common from the denominator, and simplifying we will get this one, ay minus x square divided by y square minus ax, and that is the solution for this question. And this question is look like exactly implicit function, and still we can determine the derivative dy by dx. Now look at the question number this one. So we want to find dy by dx of this function. So let us first assume that logarithm on the both the side. Also you can assume directly f of x was equal this one. Still you can get the same answer, but instead of that, whatever just I am just going to teach you, and that will be the easiest one. So y, just take log on the both the sides, so we get y times log cos x is equal x into log of sin x. But say this is f of xy, we can determine fx, that is minus y tan x minus log sin x, and if y is there, so we can say log cos x minus x cot x. But we want here dy by dx, this is the formula, but minus del f by del x is this one, and del f by del y is this one, and that is going to be what exactly your final answer. And just take here minus y tan x is there, so just you can assume that the minus common, also you can take minus common from this one, so you will get this one. So in this video we have discussed about the chain rule, total derivative, that means total differentiation, as well as we have discussed about the implicit differentiation. Thank you.